Hey everybody, in this video we're going to talk about sum of an infinite geometric series. And you might think, well, if I add things infinitely, I will get an infinite number. But that's not the case, so let's go ahead and take a look at this before we dive into the problem. So here we have an infinite series being added together, 1 plus 1/2 plus 1/4. What is the common ratio here? Common ratio is 1/2. But let's look at this visually and see what's going on. We have here's the second one, and this one we're multiplying by what? We're multiplying by 2 to get to our next part of our geometric series, our next term. So how can we look at this geometrically? Well, here's 1, and now I'm going to add a half. So I add a half right here, and then I add a 4th, and then I add an 8th, and then I add a 16th, etc. And I can see I'm never going to get bigger than 2, right? So when we add these together, it's going to fill this second pie little by little, and we're going to end up with 2. But if we do this one, what happens? We have 1, and then we add 2, and then we add 3, and we can, or 4, and we can see in this case that we are going to get bigger and bigger infinitely. So sometimes with geometric series, we end up getting a sum that we can add and get a number that's not infinity. But sometimes with geometric series, we will get infinity when we add them. So we have to be a little bit careful. The infinite sum of a geometric sequence, if A1 and R are defined in a geometric sequence and the common ratio R is less than 1, the absolute value of it. So R can't be 1. The absolute value of the common ratio has to be less than 1. Did you notice on the last portion we had a common ratio of 1/2, and that gave us an actual sum that we could find. The common ratio of 2 was infinite. But if we have an R, R that is less than 1, or the absolute value of R is less than 1, then we can find an actual sum. And it looks like this. The infinite sum is equal to the first term divided by 1 minus the common ratio. And then, but what happens if the absolute value of R is greater than 1? No infinite sum exists. So that R, looking at R, is very important for these infinite sums. Okay, so let's get back to our problem. Here we have an infinite geometric series. We need to find R. R is the common ratio, right? And if we're looking at just the sequence, we get 10, 2, 2/5, 2 25ths, and then we keep going. So to find R, we take 2, or A2, and divide it by the previous term, and we get 1/5. So this is our R value, which means that the absolute value of R, which is the absolute value of 1/5, is in fact less than 1. So an infinite sum exists. And it will be of the form, the infinite sum is equal to A1 divided by 1 minus R. So this infinite sum, the first term is 10, and then we divide by 1 minus 1/5, which is equal to 10 divided by 4/5. So this infinite sum is equal to 12.5. There's one example of an infinite sum. Let's do another. Here we're told to compute this sum, 4 plus 8 plus 16 plus 32. And you can kind of think, well, I'm getting bigger and bigger and bigger and adding more and more and more. But I need to find r just to be sure. What's the common ratio? The common ratio is 4 divided by 8. Is not 4 divided by 8. We take the second term and divide it by the predecessor or the previous term, and we get that r is equal to 2. But what happens? That means that the absolute value of r is the absolute value of 2, which is greater than 1. So, no infinite sum exists. So always check r. Here's another one. Compute this sum. Now, this one's where r is not quite as obvious, but we can take the second term, 0.09, and divide it by the first term, which is 0.9, and we will get 0.1. So r is equal to 0.1, and the absolute value of that is less than 1. So there is going to be a sum. There is going to be an infinite sum. The sum of these infinite terms is going to be a1 divided by 1 minus r. The first term is 0.9. Then we divide by 1 minus 0.1, or 1 minus r, and we'll get 0.9 over 0.9. So this equals 1. So the infinite sum is equal to 1. There's that example. Let's do one more. So here we go. We have an infinite sum. On the previous video, we talked about the sum of the first n terms, or a finite sum, but now we have an infinite sum with this geometric series. So what we do with this is we're going to write the first few terms of this infinite series. We're going to have 3/8 times 2/3 to the k power, or 1, which is going to give us 1/4. And then we're going to add 3/8 times 2/3 squared. After simplifying this, we will get 1/6. Then the next term is 3/8 times 2/3 cubed. After simplifying this, we will get 1/9. So we're adding all the way to k is infinity. So it's going to look like this. Alright, but what is r? In order to know if an infinite sum exists, we need to know r. R is going to equal my second term, which is 1/6, divided by my first term, which is 1/4, which after doing the reciprocal and multiplying, I will get 4/6. So that means that the absolute value of r is less than 1. So there is going to be an infinite sum. And I'm going to reduce r to 2/3 here, because that's going to make it simpler for when I take my infinite sum, which is equal to my first term divided by 1 minus r. My first term I found was 1/4. I'm going to divide that by 1 minus r, which is 2/3. 1 minus 2/3 is equal to 1/3. So I have 1/4 divided by 1/3, which is equal to 3/4. So this whole infinite sum is only going to add up to 3/4. And that is the sum of an infinite geometric series. We did 4 examples, all different types. I hope that this video